Hello my ninja warriors. In today's session, we are going to solve all the PYQs which was asked in April attempt of JEE Main 2024 from the chapter Inverse Trigonometric Functions. With me, I have all the data related to your JEE Main 2024 as far as your ITF is concerned. So you can clearly see on your screen that in January attempt, there were 4 questions were asked from ITF. And the same data is for April attempt. 4 questions were asked from April attempt as well. So in January attempt, there were 10 shifts. So 10 question paper were conducted in January as well as 10 question paper were conducted in April attempt as well. So both are exactly same, 4 from January and 4 from April. So out of 10 questions, if you observe, only 4 question paper were having 1 question from ITF. So you can just guess you can estimate the weightage of ITF. So in 2025, we can expect the similar pattern. Some shifts can have single question from this chapter and some shift or some question paper will not at all have any question from inverse trigonometric function. Okay. If I talk about what is the nature of the questions which were asked in April or January attempt from 2024, so I would say the question level were not that difficult. It was asked from the basic properties of inverse trigonometric functions. So I will highly recommend that you just solve each and every question which was asked in previous year question paper, especially from 2024. Okay. So let's start with all 4 questions one by one. So this video is not going to be very much big, but it is going to be very small because only 4 questions we are going to solve in this session. Okay. Are we ready for it? All right. Now, let us read the very first question. So it is given that inverse trigonometric function assumes principal values only. Okay. And x and y be 2 real numbers in -1 to 1. So they have defined that x and y. So here can you clearly see x and y both are inside the argument of cos inverse. And we know that the domain of cos inverse x is -1 to 1. So they are just saying that x and y both belongs to -1 to 1. Okay, fine. Now there is one equation given which is cos inverse x minus sine inverse y equals to alpha, where they are giving the range of alpha as well. And now they are talking about the minimum value of this particular expression. So this is actually, this variety of question is not at all new. So here what we need to do is, from the given equation, we need to we need to establish an equation, right? And from the given equation only we are going to extract the expression of this type. Once we are done with that, then we will calculate the minimum value. Okay, let's solve it out. Then we will understand. Now you know that property, right? That property is cos inverse anything plus sine inverse of same anything is nothing but pi by 2. Yes, are we aware about this property? So we are going to apply this property over here so that in this equation which is given to us, which is cos inverse x minus sine inverse y is equals to alpha. So this I want to make it completely in terms of cos inverse, right? So this is right now, this is mix of both cos inverse and sine inverse. I just want to focus on cos inverse. Okay, let's do it. So how will we do that? So this sine inverse, I'll be changing it, and sine inverse y is nothing but what? So sine inverse y from this very formula, this very identity, is nothing but pi by 2 minus cos inverse y. Yes, okay. That is going to be alpha. All right. Now can you see cos inverse x plus cos inverse y is getting formed. Okay. And on the right hand side there is alpha, and I want to send this pi by 2 towards the right hand side. Can I do that? So pi by 2 on the right hand side will become plus pi by 2. Okay, so now we are having this equation which is cos inverse x plus cos inverse y is equals to alpha plus pi by 2. Now you understand that why I wanted to change the sine inverse into cos inverse, because I want to use that formula which is cos inverse x plus cos inverse y. Okay, but for that formula there is a condition, and for that we are going to just make sure that the right hand side is not going out of the range. Okay, so alpha clearly is lying between minus pi by 2 to pi. So this alpha is lying between, tell me, ma'am, minus pi by 2 close to pi, correct? I am looking for alpha plus pi by 2. So I will be adding pi by 2 on both the sides. Can I do that? So alpha plus pi by 2 belongs to, now I will add pi by 2 over here, so 0. And I will add pi by 2 over here. So pi plus pi by 2 is 3 pi by 2, correct? So the right hand side of this, my very equation, becomes 0 to 3 pi by 2. Okay. So just tell me, cos inverse x plus cos inverse y, think about it. Now cos inverse x plus cos inverse y, so cos inverse x range is 0 to pi, and similarly cos inverse y range is also 0 to pi, correct or not? Yes. So together if you add them, so the range of the left hand side will become what? 0 to 2 pi. Okay. So can you see the range of left hand side is 0 to 2 pi and the range of right hand side is 0 to 3 pi. That means they are actually overlapping. The right hand, I am only concerned about right hand side. Whether it is going beyond 2 pi, then we need to worry about it. But right now, we don't have to worry about it. We just have to apply the direct basic formula, right? And that formula is, so cos inverse x plus cos inverse y, and that is going to be alpha plus pi by 2, correct? Now let us apply the formula. What is the formula? Xy minus square root of 1 minus x square. Square root of 1 minus y square is equal to alpha plus pi by 2. That's it. This is your formula. Let's not forget cos inverse x is already there. Okay. So cos inverse x plus cos inverse y is what? Cos inverse xy minus square root 1 minus x square. Square root 1 minus y square. Now this cos inverse, so this is what I was talking about. Right hand side, so I can just shift the cos inverse on the right hand side and we are safe to do that because we have calculated the range of both the sides and it is overlapping. Okay. So xy minus square root of 1 minus x square, 1 minus y square, and that is going to give you cos of alpha plus pi by 2. Okay, cos pi by 2 plus theta is minus sine. So this is minus sine alpha. This is xy minus square root of 1 minus x square. Obviously, we are going to square it, but we need to have some patience, right? There is a right time where we need to exactly square it out. So this is xy plus sine alpha. And now, when the moment you see that squared quantity is separated and on the right hand side, that is the best time to square. Okay. Now squaring both the sides will give you what? Squaring both sides. Okay. So this is going to give you xy plus sine alpha whole square, and from here you can see that you are getting this 1 minus x square, 1 minus y square. Okay, all right. Now you just multiply it out. 1 minus x square minus y square plus x square y square is your right hand side. And the left hand side becomes what? X square y square plus sine square alpha plus 2xy sine alpha. Correct? Okay. And obviously, from the right hand and left hand side, one term is cancelling out, which is x square y square. Okay. And now what I'm going to do is, let us just shift x square plus y square on the left hand side, and there is plus 2xy sine alpha, and 1 minus sine square alpha is on the right hand side. So this is going to become cos square alpha, right? So this is what you were looking for. Let me just go back and tell you that over here x square plus y square plus 2xy sine alpha is what they are looking for, and the minimum value of that. So my value is coming out as cos square alpha. Okay. Expression value is cos square alpha. And we are looking for the minimum value, right? So basically, if this expression is becoming cos square alpha, then the minimum value of cos square alpha is what we need to look for. Overall, any squared quantity, so cos square alpha minimum value is 0, but they are actually giving the value of alpha range. So alpha becomes pi by 2, then it will become 0, and it is actually permissible as per this range. Alpha can be pi by 2. That means the minimum value is 0. Like less than 0, I cannot get any minimum value because squared quantity cannot be negative. The minimum possible value of any squared quantity is 0. Once you get the 0, just forget about anything because we cannot go less than that. So the final answer of this question is clearly option A. Okay, all right. So this was a good question, I would say, and not very easy, not very difficult, yeah, but a little bit effort. But these kind of questions, I am not saying that this is a very new type of question. You will find these type of questions in many books and in many notes as well. Okay. So now is the time that we should move on to our next question, which is this. Okay. So, all right, let us read it out. It looks good, right? For n belongs to natural number, so cot inverse 3, cot inverse 4, cot inverse 5, cot inverse n is nothing but pi by 4. Then we need to figure out n, okay? So I have already told you when I was teaching inverse trigonometric function in row series also, I already told you that tan inverse is the favorite of all trigonometric function. If you ever get a chance to convert everything in tan inverse, do that. Do not even think about it, okay? So what we are going to do is we are going to follow the same thing. Tan inverse 1 by 3, because this is the property, right? Cot inverse x is equals to tan inverse 1 by x, especially when x is positive. Okay, we don't have to bother about that when x is positive. Okay, but if x is negative, then this is not true. We need to add pi, right? So tan inverse 1 by 3 plus tan inverse 1 by 4 plus tan inverse 1 by 5 plus tan inverse 1 by n, okay? Because n is also a positive, natural number is a positive, is equals to pi by 4. So this three things, the 3, 4, 5, this we need to solve. You know which formula we are going to use, yes or no? So we are going to use the formula which is tan inverse x plus y upon 1 minus xy is equals to tan inverse x plus tan inverse y. This is the formula which we are going to use. All right, too. Clear? Tan inverse 3 plus tan inverse 1 by 4. Tan inverse 1 by 3 plus tan inverse 1 by 4. Let us first apply the formula in these two. So what we are going to get is tan inverse 1 by 3 plus 1 by 4 whole upon 1 minus 1 by 12. Okay? And can you see the denominator is positive? So we don't have to like worry about anything, adding anything, any pi, any constant. Okay? All right. So basic, the direct formula we can apply it over here. And this is tan inverse 1 by 5, tan inverse 1 by n is equals to pi by 4. Correct? Okay. Now again, if I solve this out, so this is, if I take LCM, 7 by 11. So this is tan inverse. So if you solve, this is 7 by 12 and this is 11 by 12. So 7 by 12 can I write directly? 7 by 11, right? Okay. 3 4s are 12 and okay. Correct kiya na? Haan. So 7 by 12 and 1 minus, correct. Plus tan inverse 1 by 5 plus tan inverse 1 by n equals to pi by 4. 1 by 1 we will tackle it out, okay. So tan inverse 7 by 11 plus 1 by 5 one more time. So 7 by 11 plus 1 by 5 whole upon 1 minus 7 by 55, correct, okay. So plus again tan inverse 1 by n plus, sorry, equals to pi by 4. Okay, so let us just solve it out on the next slide. Tan inverse 7 by 11 plus 1 by 5 upon 1 minus 7 by 55. Tan inverse 1 by n, that is going to be pi by 4. All right, okay. So this is tan inverse 55 minus 7. Tell me, 55 minus 7 is 48, right? And this is 7 5s are 35 plus 11. 55, 55, you can cancel it out. Plus tan inverse 1 by n is equals to pi by 4. Correct? Okay. Now this. So this is 46. Okay. So tan inverse 35 plus 11 is 46. So 46 by 48 is 23 by 24. Can I write it directly? Now we are very close to get the value of, so this is just a basic calculation problem, right? Tan inverse 1 by n, can you see that this is like smoothly one step, no logic applied, just we are solving. So that's why ITF will give you easy marks, right? Usually. one or the other time, like there will be rare times that it will give you the problematic questions. Okay, now we have shifted everything to the right hand side, everything constant I am talking about, and n I am keeping it on the left hand side. Okay, now this pi by 4, so this is actually tan inverse 1 minus this is tan inverse 23 by 24. Okay, now you know the formula, tan inverse x minus, so this is the without any condition you can apply this formula. Tan inverse x minus tan inverse y is equals to tan inverse x minus y whole upon 1 plus xy. So this is tan inverse 1 minus 23 by 24 whole upon 1 plus 23 by 24. Okay, so finally, let me change the color. Okay. Finally, what I'm getting is 1 by, so this will become what? Tell me. 24 minus 20. So 1 by 24. So this is tan inverse 1 by 24 upon, this is 47 by 24. Okay. So actually this is coming out as tan inverse 1 by 9. Did you notice? Tan inverse 1 by 9 finally, okay, 1 by 9, 1 by n is tan inverse 1 by 47. If you compare right away, n is coming out as 47, and bingo, your answer is right here. Alright, so the second question, beautifully done. The answer is 47. Okay, alright, shall we move on to the next problem over here? Okay, alright. Now you can clearly see the third problem from ITF is actually a combination of integration and basically definite integration and ITF. But trust me, the integration part is very less. So I will say that 90% this is trigonometry and 10% is the integration part. Okay, so the very basic, this whole expression will be turned out to be very basic expression. Okay, so the whole problem is all about how to convert cos to cot inverse square root 1 minus x upon 1 plus x. Okay, so let me just go back and rewrite this expression, right? So the expression was cos of 2, then we have cot inverse square root 1 minus x upon 1 plus x. I know that right now the expression looks a little bit difficult, right? Let me just check. Cos 2 cot inverse root 1. Yes. Okay. So can you see cos of 2? What we will do is, I have already taught you this in ITF in the very beginning, that sometimes the question is so easy, you just have to do that right angle triangle thing. Okay. So this I will assume as theta. Yes. So you are left with cos 2 theta, and this cot inverse square root 1 minus x upon 1 plus x is theta. What does that mean? Square root 1 minus x upon 1 plus x is your cot theta. Correct? Let us keep it as it is for now. Now this cos 2 theta, I have multiple formulas. Okay, cos 2 theta ke what are those formulas? 2 cos square theta minus 1, but that will not help us over here because it will, this cos 2 theta will again become cos, and now we are having this cot theta. No, again sine 1 minus 2 sine square theta is also not happening. The third formula, which is 1 minus tan square theta upon 1 plus tan square theta will be in our favor. Yes. So what we are going to do is, let's convert this in tan theta. Very easy. Cot theta is this, then tan theta will be reciprocal of this. So 1 plus x upon 1 minus x. Right? This is your tan theta. So why not we plug in this value over here? 1 minus tan theta whole square upon 1 plus tan theta whole square. That's it, right? Cos 2 theta was the original question and cos theta is this. Now we are just here to put the value of tan theta from here. Can I do that? Yes, definitely, right? So 1 minus square root 1 plus x upon 1 minus x whole square, correct? Upon 1 plus square root 1 plus x upon 1 minus x whole square, right? So this is actually going to become 1 minus 1 plus x upon 1 minus x and 1 plus 1 plus x upon 1 minus x. Let us solve it out. So 1 minus x minus 1 minus x upon 1 minus x. Taking LCM, basic. 1 minus x plus 1 plus x upon 1 minus x. Correct. Minus x plus x gone. 1 and 1 is also gone. So we are left with minus 2x upon 2. So minus x is the final answer of this expression. Okay. Alright. So we just have to integrate minus x. So this whole expression turned out to be minus x. We need to integrate this from 1 by 4 to 3 by 4 with respect to dx. Can you imagine? Now if I integrate minus of x square by 2 and this is 1 by 4 is lower limit, upper limit is 3 by 4, right? So this is minus and now 3 by 4 square, 1 by 2 also if I take common, minus 1 by 4 square, correct? So this is 1 by 2 with a negative sign. 9 by 16 minus 1 by 16, so 8 by 16. Minus 1 by 2 into 8 by 16 will give you what? Tell me. Minus 1 by 4 as the correct answer. Option C is absolutely right. Okay, all right. Option C. Just tell me whether you have understood it or not. So third question done nicely with the flying colors. All right. So now ITF is actually making me happy because I feel that there is no question which is actually uh, irritating you, right or wrong? है ना? चलो. Now next, let the inverse trigonometric functions take principal value. So this is the last question. Inverse trigonometric functions take principal values, the number of real solution of this equation. Okay, all right. So again, I can see the same thing. Sine inverse and cos inverse are together. So why not make use of sine inverse x plus cos inverse x equals to pi by 2, this very identity. Okay, so 2 sine inverse x plus 2 cos inverse x. Can I write it this way? So just let me rewrite this expression. 2 sine inverse x plus 2 cos inverse x plus 1 more cos inverse x. So what did I do? I just wrote 3 cos inverse x into 2 cos inverse x plus cos inverse x, and that is going to give you 2 pi by 5. And this is 2 times pi by 2. 2 times pi by 2 by using this identity, correct? Plus cos inverse x equals to 2 pi by 5, correct? Okay. Now cos inverse x will become what? 2 pi by 5 minus pi, which is minus 3 pi by 5. Cos inverse x is minus 3 pi by 5. All right. Did you notice very important thing? The range of function y equals to cos inverse x is 0 to pi. That means this y belongs to 0 to pi. Okay. 0 to pi. 0 be close, 0 be close, pi be close. Okay. And can you see, so cos inverse x value cannot be negative. So can you see cos inverse x is minus 3 pi by 5, which is actually not possible. Okay. So if it is not possible, the number of real solutions will be 0. All right. Okay. Clear? Yes. Now, so this was last question. One more thing I would like to tell you about, that is the Tattva books for JEE Main PYQ, right? So Tattva book for JEE Main PYQ, if I talk about, right? So if you want to solve more PYQs, the previous year, JEE Main 2023, 2022, 2021, so do check out the Tattva books for JEE Main questions. And we have Tattva books for JEE Advanced problems as well. Link is already given in the description box. So do check out that. Also, another thing is which next chapter you want in this particular series, do comment below so that I will upload that video super soon. Okay. All right. So this is me, Namrata, signing off. I'll see you all in next video.